Good afternoon, one and all present here once again. I, Sandeep Tuli, Assistant Professor, Department of Computer Engineering, Poornima Institute of Engineering Technology, Jaipur, welcomes you all in this third session of day 5 of the first short-term training program under AICTE AQIS on image processing and its application. In this session, we are going to have a discussion on pattern recognition. And for that, we have with us Dr. Deepak Ranjan Nayak from MNIT Jaipur with us. I welcome you, sir. Dr. Deepak Ranjan Nayak is an assistant professor at Department of Computer Science and Engineering, MNIT Jaipur. Prior to this position, he was an assistant professor at the Department of Computer Engineering, SV National Institute of Technology, Surat, India. He worked as a postdoctoral fellow at IIT, Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, Chennai. During January 2019 to December 2019, he received his PhD degree in Computer Science and Engineering from National Institute of Technology, Rourkela, and he has published over 40 articles in peer-reviewed journals and conferences of international repute. His current research interests includes medical image analysis and classification, machine learning, deep learning, pattern recognition, and computer vision. His publications have around 600 citations, H index of 13, and I-10 index of 15, Google Scholar. On one of his papers was included in ESI highly cited papers. He has received international travel support from Department of Science and Technology, that is GST, Government of India in 2017. He has also received the Outstanding Reviewer Award by Computers and Electrical Engineering Journal elsewhere for the year 2017. He serves as a reviewer of many peer-reviewed journals such as IEEE Transactions on Circuits and Systems for Video Technology, IEEE Journals of Biomedical and Health Informatics, IEEE ACM Transactions on Computational Biology and Bioinformatics, Scientific Reports, IET Image Processing, IET Computer Vision and Image Understanding, Pattern Recognition Letters, Computer Methods and Programs in Biomedicines, Biomedical Signal Processing and Control, etc. He has also served as a technical program committee member of several conferences of international repute, and he is a member of IEEE. We welcome you, sir, and I humbly request you to enlighten us with your knowledge. Over to you, sir.
Thank you so much, sir. For the good afternoon, one and all present over here. My name is Deepak Ranjan Nayak. I'm a faculty in the Department of CSC, MNIT Jaipur. So in this lecture, what I'm going to discuss is introduction to pattern recognition. So I hope you all have learned so many things in image processing, the introductions to image processing, several stages of image processing like image enhancement, noise reduction, image restoration, image segmentation, image compression, and all these things. So now is the time to solve some real life problems by means of image processing algorithms as well as some machine learning algorithms. So what I'm going to discuss in the next 1.5 hours is the definition, the formal and informal definition, what a pattern exactly is, and what pattern recognition is all about, and what kind of problems are coming into this category, and what are the different methods which are currently being used for solving varieties of pattern recognition problem. So before I start the definitions and the formal definitions of pattern recognition and all, so let us first discuss what is meant by a pattern. What is meant by a pattern? So pattern is nothing, any object that you see in the world that forms a pattern. Say, for example, let's say you are capturing some images of a tiger. Let's say you capture one images of a truck. So every object in the world is associated with a pattern. So the pattern is something which describes what we see in the real world, what we hear. So whatever I'm speaking right now, that also forms a pattern. If I will be capture this a signal by means of a speaker or a oscilloscope, so that signal will also be a pattern. So, but what we were focusing on in this particular session, and maybe in the next two sessions tomorrow, is mostly the images, because the workshop is very much centered towards images. So we'll be mostly focusing on images. Whenever we are talking about patterns, means we will only find patterns on the images basically, because this is limited to this workshop, and that we will see throughout this my session. And so, as I already said, that pattern is something which describes what we see in the real world, and what we hear, what we sense. Everything is everything, every object that forms a pattern in the world. So, coming to the human perception, so what exactly we want here? So, pattern, the formal definition, if we're talking about, then a pattern is an abstract object, such as a set of measurements describing a physical object that we have already discussed right now. So, but what is the job of the pattern recognition here? The pattern recognition is nothing but I will again come back to this slide. The pattern recognition is the scientific discipline whose goal is to classify the objects into number of classes or into the number of categories. And these objects can be either images or signal waveform or any type of measurements that need to be classified, maybe spoken words or maybe signals and other things. So, in pattern recognition, what we are going to discuss is the theory, the algorithms, and the system, which are basically used to put the patterns into different categories. And the job of the pattern recognition is that, so we have to enable the machine to find the pattern. So what we want? We want to design a machine. That machine should be very intelligent as we are. So the concept of pattern recognition lies in the very early efforts of the intelligence as well. And if you see that and here are some of the patterns, examples of the patterns, handwritten characters you can see on the screen. There are some handwritten letters I have shown here. These are also forming some patterns. So there are some barcodes. There is something called as fingerprint biometric, which also forms a pattern. So everything, every object in the real world, so always forms a pattern, as I mentioned. So what exactly we want here is the pattern recognition is the study of how machines can observe the environment. How will you make your system intelligent to find the patterns, and to learn distinguish patterns of interest, and to make sound and reasonable decisions about the categories of the patterns. So that is what the human and machine perception is. So we have to make our system or enable our system or machine to all the pattern recognition tasks. So as I already said, that the origin of the pattern recognition lies in very early efforts of understanding intelligence. So what is intelligence? And it can be defined as the ability to comprehend, to understand, and profit from experience. In other way, we can define intelligence as the capability to acquire and apply knowledge. Every day, whenever we are seeing something around us, whenever we're watching something around us, so we used to capture some knowledge, sometimes intentionally and sometimes unintentionally, sometimes unknowingly and sometimes unknowingly. So we are capturing something, some knowledges, we are acquiring knowledges, and the moment we require it, we apply it. So to understand this concept, I would like to show you something. So this is what I would like to tell you that where exactly the origin of pattern recognition lies in. So if I will ask you the question, can you recognize these two images? The answer is obvious. Yes, the left side images is nothing but the Statue of Unity, I think situated in Gujarat, and it is nothing but the statue of Sardar Vallabhbhai Patel, and the right one is nothing but the statue of APJ Abdul Kalam. So now the answer is so obvious to everybody. Yes, this is nothing but a statue of unity, and the right one is nothing but the statue of Dr. APJ Abdul Kalam. So my question here is: have you ever asked yourself that how do you recognize it? So the question here is, and the answer is everything. The answer is nothing but the definition of pattern recognition, the definition of machine learning, and the machine intelligence as well. So how do you recognize it? Is there anything there in your mind? Or, how do you recognize it? So either the answers can be either you visited the place, Statue of Unity, where it is present, or your parents have shown you the pictures, or you have gone through some of the articles or some of the articles in the newspaper or maybe in the YouTube, that this is nothing but the picture of the Sardar Vallabhbhai Patel, and this is exactly is nothing but the Statue of Unity. Either you have read it from your books, or you have been seeing this picture from your childhood. That's it. So you have already this experience. You have already seen this type of images in earlier times. So now what are you doing? So unknowingly at that time, what happened is whenever you see an object, a new object or an object which you've already seen, or a new object, so unknowingly the pattern is mapped to your brain or mapped to a model which is already embedded in your brain. That is unknowingly. And the next time, when right now I'm showing these pictures, now what are you doing is you are simply, right now also you are extracting some of the descriptors from it, and that descriptors is right now you are matching with the model which is already featured in your brain, and now you could able to tell that yes, this is the photo of Sardar Vallabhbhai Patel, and this intelligence we are already having. God has given the power to us to recognize this thing. Even if I will show you thousands of images of similar categories, you can able to recognize it. But if I will show you a picture of a common person which you don't know, then at least you can say this is a person of a, I mean, this is a picture of a person. I don't know the person, but this looks like a person. That's it, you can say, because you have never had that. You have never had that experience before. That the person which I will show you that you don't know, that means you have never seen, and that type of patterns is not there in your brain, in your model. So I hope you understood at least that how exactly the intelligence is there in your mind, and we want to mimic that intelligence in the machine. We want to make our system more intelligent. And the pattern recognition is, as I already said, this is nothing but recognizing patterns by means of the machines. And for that, you may need the help of the image processing algorithms and machine learning algorithms. So sometimes people get confused. People get confused with the term pattern recognition, machine learning, sometimes machine intelligence, and sometimes now people are talking about deep learning and all these things. So I will show you one figure in which I will tell that how different and how similar pattern recognition and machine learning are, and how important and how related both they are. So just for now, you remember one thing, that pattern recognition is nothing but a problem, but machine learning is nothing but a solution for this. So this is what the difference between the pattern recognition, but all are quite related among each other. So coming to the applications of pattern recognition, I think a lot of applications you are currently being used as well. I think in your institute, you perhaps every day you are putting your finger on the biometric machine, which is called as a personal identification biometric recognition. Varieties of biometric recognitions patterns are there. Face modalities are there. Face biometric, iris biometric, and fingerprint. The fingerprint is one of the most popular one, but iris is also one of the most powerful one. I hope you both, I think these both have been captured whenever I think you all have registered for Aadhaar, and during the Aadhaar registration they have taken two different types, not only single only fingerprint, both iris and fingerprint, and this is the current research. Initially people used to tell, yeah, fingerprint is sufficient to recognize a person or to identify a person or to verify a person. So then people used to call, no, iris is more powerful. Then sometimes people call your face is more powerful. So the current scenario, the current research work in this particular field is multimodal biometric. So can you extract the patterns from each of these biometric modality and combine together, form a very powerful descriptor, and then and then give it to the model to predict whether the person is authorized or not. So that's it. And one of the most famous and successful application of pattern recognition is nothing but optical character recognition. Optical character recognition, you all know that how difficult it is sometimes whenever you will write, whenever I mean you are recognizing patterns, handwritten patterns basically. So it's very pretty difficult task. I will also show you the figure on the figure later on. And document classification. Document classification is very in one of the also famous applications of pattern recognition. And one more application is in medical domain is computer-aided diagnosis. Tomorrow we will be discussing on that, including the COVID-19 screening process, so how pattern recognition algorithms are helpful for diagnosing COVID-19 and some other applications as well. So tomorrow we will be discussing and industrial automation, a very very powerful applications. Industrial automation. You want to set you want to set the products. You want to fruit setting, fish setting. You want to set the fruits based on the categories, based on the quality. So then how will you sort? So this is what is again a pattern recognition task. Remote sensing. You want to classify the remote sensing hyperspectral images into different regions. For that again you need the help of the pattern recognition system. So finally, bioinformatics and a lot of other applications are there in pattern recognition. I will show you one by one. The first one is nothing but English handwritten recognition. The right one, if you can see, very difficult even sometimes for us to understand. We are a little bit intelligent. We all know that, and what we want is we want to simply mimic a human brain by means of some algorithms, machine learning algorithm or pattern recognition algorithm. So the very difficult English was a little bit pretty easier, and people have already solved the problem. Even Adobe system, I hope you all are using Adobe Reader for opening the PDF files and others. In Adobe, actually, people are even three of my students they are working currently, and they are particularly involved in this type of research work. So they are getting very high packages because Adobe usually gives that type of packages, and they usually prefer the students who are expert in machine learning and pattern recognition, basically in the field of handwriting recognition. So very very important. And coming to the other other languages like Indian languages, Urdu, whether it is Hindi, whether it is Devanagari, Bangla, Odia, a lot of Telugu, dangerous, very very, because a lot of letters are there. In English there are at least 26 characters, and but in Odia it is 49. In Bangla maybe it is 51 or like that. So it is very very difficult again when it comes to handwriting recognition. So pretty important. And it has been a long-standing problem. Till now, people are solving this problem, and varieties of related problems as well. And coming to, we have already discussed about these biometric things and the biometrics. If you can see out here, and something called as fingerprint, and the very interesting biometric people are using right now is ear biometrics. And even I received one paper a few days back that they have done something called as, even you can see here the ear picture out here. They are, I don't know how they are applying, but they are claiming that leaves are also can be used for person identification. I don't know how, but they are using. And the current scenario, as I already told you, that you can see the last image, the fusion of the face, the multimodal biometric recognition, the current research scenario in this particular biometric domain. And a lot of automations are going on, pattern recognition applications, so automated car driving. And these, particularly the Mercedes-Benz is currently working on. Even one of my students luckily got 2 years back in Mercedes-Benz. He is currently involved in this project. So how to automate the car driving? It is in India, it is very difficult to do that, because we all know that there's a lot of objects are moving around in our roads and this, but still they're trying to find out very good solutions for automatic car driving. And in US already, people are already using this type of thing. Very interesting. And coming to the cancer detection one, given a medical image, here we will not use the simple images, I mean the natural images. Instead of that, there are some medical imaging modalities, like this image is a microscopic image, and the job is to locate where the abnormality is present, or is to classify this image into either normal category or abnormal category. So very important applications, and a lot of companies are currently working as well. Even Philips and a lot of other companies, which even Intel as well, they are currently using this type of technologies, pattern recognition, and these for solving these medical imaging problems. And a land classification problem, where there is a tree, where there is a land, where there is sometimes it is required, and to land classification problem. And there is something called as building and building group recognition using satellite data. You have to find out whether there is a building present in the data if you are capturing the images from the satellite. Satellite imaging is itself is a very important area. Hyperspectral imaging itself is a very important area. These are the branches of the image processing, you remember. Medical imaging, hyperspectral imaging, very, very important, and the advances in image processing as well. So pattern recognition application, if you are talking about this one is very, very important. This one is why it is very, very important is the license plate recognition. In most of the, I mean, in some of the, yeah, not most of the, in some of the smart cities in India also, they have deployed some algorithms to recognize the license plate, to find out the culprits, that whether they are obeying the rules or not, whether the traffic rules or not. So if they're not obeying, let them go, and definitely they will find sleep when they will reach at their home. So the license plate detection is pretty important for anomaly detection as well, and it's a kind of again pattern recognition problem, and it also requires the optical character recognition concept out here. So it's been a long-standing problem till now. People are using, and it is required in India. It is still now. It is not a good algorithm, you can say, a reliable algorithm till now not yet reported. So you can also work on this particular area. The final one is nothing but a clustering of microarray data to cluster to group the DNA RNA pattern of this particular patterns. And coming to one example, so let us discuss only one example which is there in the Judah Hutt book, which is one of the most famous and most popular book for pattern recognition, and from that book itself, I have taken this example. This example is nothing but this says that there is a fish packing company, and the job is to sort the fish. It is coming by a conveyor belt, and you have to sort it. And the fishes are of two qualities. I mean, two different types: sea bass and salmon. Very actually, costly fishes, both of them are, and mostly found in the sea. And then how do you distinguish between these two fishes? So fishes looks very similar to each other. Then is there anything, and you want to automate the process, you don't want to check one by one in between, you want to assign one particular guy for this. So what you want is your model, I mean, you want to fix a camera which will capture the images, then will run the algorithm. You will run the pattern recognition algorithm that will capture the features or the descriptors from the images, and then that descriptor will be helpful, and that descriptor will be provided maybe later on to some of the recognition algorithms like classifiers to classify into two different categories, sea bass and salmon, and then based on that, that will automatically classify. So very interesting actually the concept is, and now the question is, so can you guess that what type of feature or what type of descriptor you will consider that will make you that will make you find that yes, there is a difference. By using this descriptor, you can differentiate the two fishes. I mean, you just consider, say for example, if I will tell ask you one question, that how do you distinguish a cat and a tiger? So you all know the size of the cat and the size of the tiger are different, but the looks, if you see, sometimes the cats are looks like tigers, but looks, but the other properties. So I cannot take some feature or some descriptors which are redundant or which are similar in both the cases. That I don't want. I want some relevant features, some meaningful features, some discriminant features, as well as some distinguishable features. So I don't want that type of features which will create some confusion or which will add difficulties in the model. So one of the features, or the features could be here: the length, maybe the width, maybe the weight. Weight doesn't matter, I don't think so. So number, and I mean, it could be anything. So the problem, you will definitely find some of the problems whenever you will capture the images through the camera. So maybe there are some lighting issues. Maybe there will be some lighting issues. Maybe there will be some noises. Whenever I think you have already learned about the noise reduction techniques, and in the I think other speakers have already discussed about it. And here is the time to apply those techniques as a pre-processing technique before passing it to the pattern recognition algorithms or machine learning algorithms. So there may be some difficulties initially, but you have to remove those type of unwanted information which are there in your emails. So the steps could be like that. Initially, you have to capture the image, then isolate the as I mean the manual process. The manual process. If you don't want to, treat a camera and do the automation process, then what you have to do? We have already discussed about it. So we have to isolate the face manually. You have to take the measurement. You have to tell. Then you have to take the decision. Finally. So let's say I have contacted or I talked to some fisherman, and he told, based on his experience, long experience, he told that sea bass is generally bigger in size. Generally, it's not always. It's generally bigger than salmon. But then that means length could be a good feature for this type of classification problem or pattern recognition problem. So my question here is, only this feature, using this feature, will it lead or is it sufficient for correctly classifying or recognizing the patterns, two different patterns? Sometimes no. One feature is very difficult, using only one feature to distinguish the patterns, and that depends upon the problem you are going to solve. So most of the cases, you all know that one feature is not at all sufficient to classify the complex patterns. So you may require more number of features. But again, the question is, you can see the first feature here. Let us consider one more feature, lightness. Maybe the lightness means maybe the sea bass is more clear or more white, and there are some pieces which are black in nature. I mean the surface. Some of the surface of this particular piece is black in color. So maybe that can be one of the another feature. I'm not saying these are the two, I mean, powerful features or distinguished feature. Just say, for example, we're considering like this. And finally, what we could achieve is, so now the feature vector. So the important thing here is, so why we're talking about this feature vector and this? Because finally, you remember one thing, you finally want to give it to the machine to take the decision. So that is why these type of patterns should be represented in a form which machine can understand. And whenever I am seeing something or hear something, whenever I'm capturing some images of this space, this has to be represented by some descriptors, unique descriptors or features, and these features should be arranged in a particular fashion, and these fashions and these arrangement is called as a feature vector, or sometimes called as a feature space. And because here the features are features can be represented in two-dimensional space. So this is what the concept of the feature vector is, and here the feature vector is a two-dimensional. And why it is required? Because it can be easily understandable by the machine. And initially the images are there. Whenever you are capturing, you all know that how to convert an analog image to digital image. Whenever you are capturing this images using some digital camera, it automatically does that. And whenever you are loading into a digital computer, and it is by means of sampling and quantization, the two techniques to find the discrete intensity values as well as the coordinate values. And after all, those values are nothing but the integer values, and that are and if the images are 8-bit and grayscale, and I mean if the images are color black and white and binary images, then obviously then it is a 8-bit one. So binary is different, but if it's a grayscale and black and white images, it's an 8-bit one, and the intensity values ranges from 0 to 255. And this image is whatever we have considered right now is the grayscale images. So all the pixel values are integer values and the discrete values, and it ranges from 0 to 255. And if it is a color image, you all know that color images having three different planes, red, green, and blue. And for a particular pixel, there will be definitely three different intensity values, each for one plane. So for all the planes, the value again lies between 0 to 255. So now the question or whatever we have discussed will again, if I ask the same question to you, are these two creatures sufficient to describe the pattern or to clearly distinguish the pattern? That we can't say. That we can't say. But I mean, the experts can say that we cannot say. We have to test it that whether these tools are really good or not. And sometimes you doesn't. I mean, you don't think that these two patterns, I mean, these two features are sufficient. And there is people always think let us add more number of features to get good application, to get good performance. That is also not correct. More number of features may not always give you good results. Sometimes it may lead to overfitting problem because of the complexity present in the data. So that I will discuss what is actually a overfitting problem. That is a major concern whenever you are designing some machine learning and pattern recognition system. So coming back to the classification, as we are talking about a classification problem. So classification problem, when you will be solving a classification problem by means of a classifier or some statistical classifier, and the statistical classifiers are based on various of the properties. I mean, various of characteristics. They have been categorized into various types, and one of the type is a designing decision boundary, otherwise called as a discriminant function. Y is equal to mx plus c. And in machine learning and pattern recognition, the common terms are wx plus b. Wx plus b. I hope you all have aware about this particular equation, the equation of the straight line. And there are some classifiers which are based on probability distributions, like naive Bayes classifier, which I'm going to discuss today. And there are some classifiers which are tree based. There are some classifiers which are nearest neighbor based. So this is there are varieties of classifiers present in the literature, and one of the most famous one is the drawing the hyperplane. I mean, the drawing the decision boundaries, and the neural network SBM, all are based on this type of categories. And you all know the importance of SBM and the neural networks. So, but this is, I mean, how will you draw the straight line? So, is there a single straight line? I mean, can you draw a single straight line to classify the samples? So here there are two, samples of two categories, Salmon and Seabass. If you can see that the points are nothing but the data points, lightness and width. So this is a two-dimensional data point. You all know that. And the circles which are shown in black color here represent Salmon class, and the circle which are represented in red color are nothing but the sea bass. So if I draw this straight line, which you can see on the screen, so there are some misclassifications. There are some misclassifications. So can I draw something else, or like some curve, so which can correctly classify all these samples. And these are all training samples. I will also be discussing about training and testing. So yeah, this is the one. If you draw a hyperplane, if you draw a curve like this, then only if you see now this hyperplane could able to successfully classify all the samples of both the categories. But these type of decision boundaries are not at all accepted, because it is a very complex, very complex one, and it will definitely lead to overfitting problem. And this type of decision boundary you will get if you will train your model for longer time. So that means that the model complexity will be very high in this case, and the most suitable one is this one. If you can see, so right now, although this is nothing, but this could be find out by using the WX plus B. Either if you apply the neural network architecture, multi-layer conception, then you may able to get this type of thing. So the important thing here is, if you see, the previous one is a bit dangerous, as I said, that whenever a new sample of this category, of this even black category, will come here, so maybe it will classify wrongly. So this type of curves, and you can say decent boundaries, are not at all acceptable, because it leads to overfitting problem. So the best way is to represent this way. So you have to, although there are two misclassified sample, but still it is okay. Still it is okay. And coming to the pattern recognition system. So what is the pattern recognition system out here, and how do you define and what and how it works? What are the stages involved in the pattern recognition system? So let us discuss one by one. If you look at the training data, so generally whenever we are having some patterns, we are having some samples. Let's say we are going to solve a image classification problem. You want to classify, I mean pattern recognition problem. You want to classify the animals into two categories, cat and tiger. So now you are having some samples. So like human beings or machine also will learn from the experience. So we have to provide some samples to learn the model, to build the pattern recognition system. So for that we have to collect a lot of samples for that. And let's say I'm having 100 number of samples from each categories, 200 samples, 100 for category, 100 for tiger category, 100 for cat categories. So then what we have to do is we have to initially divide the data into two sets, the data set into two sets, training and testing. And there is also something called as validation that we will be discussing later on. But for now, just remember, so the generally data set is divided into two types. One is training set and one is testing set. And the training set is basically used to design the model, to learn the model, to build the model. And the testing set is totally independent from the training set. We should not, there should not be one common sample which is present in both the data set. So actually the intersections of both training, I mean the intersection of training set and testing set should be fine. So the training set is different, testing set should be different. And the testing set, you should not pass any of the samples from the testing set to the model during the model development, I mean the design of the model. So whenever you will design or whenever you are training the models, you are building the model, you have to pass only the training data. And that is why in this picture, if you can see, which is on your screen right now, so we have started with training data. Then as I mentioned that sometimes you may require the help of the pre-processing techniques, because your images may be contaminated with some unwanted information and some other things. Maybe your images are low contrast in nature, so you have to apply some histogram equalization. I hope it is also covered in image processing. So all are interlinked, all are useful whenever you are building a machine learning system or a pattern recognition system. So again, then after that, there is something called as the feature extraction. The most vital stage is feature extraction. That what type of feature you will extract from those images, from those cat, or from those many samples of the cat images, or those many samples of the tiger images. So the features can be shape features, geometrical features, color features, background features, the patterns which are present on the body of their animals, and maybe the transform features, and maybe the features can be calculated in the pixel domain, maybe in the frequency domain, and sometimes the frequency domain features are much more powerful. And sometimes you can apply, even I hope also the image transformation has also been applied, I mean has also been discussed in your other sessions by the other speakers. Image transformations like Fourier transform, wavelet transform. There are a lot of variants of wavelet transform, stationary wavelet transform, and there are a lot of other transforms are there, correlate transform, contourlet transform, which are pretty good. Then even wavelet transform and other transform. So you can also apply those transforms on the images, and you can extract some statistical features or those features on the frequency domain, and then you can apply some machine learning algorithm, or you can the statistical classifier to recognize those patterns by using those features whatever you have extracted. So one more important stage after feature extraction is sometimes feature selection or feature reduction. Feature selection is actually a bit different from reduction. So feature reduction, I mean, if the number of features, whatever you have extracted by means of some algorithm, image processing or signal processing algorithm, are very, very large in numbers, and then what you will do? If the number of features, as I already mentioned, it will be very high, and that also, again, if the number of features are more than the number of sample, that always create a sample size problem, small sample size problem, triple S problem. So in that case, there will be problem. So what we have to do here is we can apply some feature reduction technique like principal component analysis, linear discriminant analysis, and there are a lot of other technologies available in the literature, what you can apply over there is this PCA just to reduce the dimension. But the feature selection is something different. The feature selection, you have to select the features, whatever the features are there, you have to select. I mean, the subset selection. It's a kind of subset selection. You have to select the particular feature. Yes, this feature is relevant, so you will pick up that feature for your final calculation. So then after all, you will build the model and finally you will get the output. You will get the, and you will take the decision based on that. And in the real time, maybe in testing time, whenever you will have some, I mean, you can pass again those, you can pass those images into the similar, stages, but the model is already trained. The machine learning model, the classification model is already trained, and you need not to apply once again the model, and the model is already trained, and you have to pass the images to the trained model, whatever is designed using the training set, and finally you will get the output. So this is how the pattern recognition system works, and these are the different stages which are currently being used. And in each of these stages, you can do research. Like feature extraction itself is a domain of research. Feature visualization, data visualization is a very important domain of research. If you can, you see, why this is very easy to but tell. I mean, this figure. Looking at this figure, you can easily tell. Oh, this distance boundary is good. This distance boundary is not good. But here the number of features are only two, and if the dimension is two, then you can plot it and you can see it. But the question is, in real time, the number of features will not be two. Maybe it is 1,000, maybe it is 1,000, maybe it is 5,000, maybe sometimes it is 10,000. So then how would you visualize it? That itself is a research area in pattern recognition. So these are very, very important things, whatever we have discussed in the first part of this lecture. So in the second part of this lecture, what I'm going to discuss is one particular, recognizer, or you can say classifier, which is a very common and a very, useful as well, and very popular. So coming to the very, very important, those who are actually working in this field, to know the fundamentals of this pattern recognition and machine learning as well. So Sandeep sir, are you there? हेलो संदीप सर।
हाँ जी सर।
हाँ जी सर, चल रहा है सब ठीक ठाक, सुनाई दे रहा है?
हाँ जी बिल्कुल सर, सुनाई दे रहा है सर।
ओके ओके ओके, सो लेट मी discuss the second part of the discussion. I just want to actually I just want to ask the participants, actually those who are at least attending, I mean 34s, are they getting something from it? Are they find something useful from this? So let's have a 1 minute and 2 minutes of actually break, and in between that, let's have can you please write your comments in the comment box? No, I have not yet received a single comment from the participants. I got a response from Professor Deepak Mode. Yeah, it's nice session, sir. So I hope it will be useful to all of you. And these are the basics part. There is nothing new in it, and these are very basic and very fundamental as well. And if you will understand the concept, then I hope you can think of solving a variety problem. What tomorrow we'll be discussing, and tomorrow also I will be showing you some hands-on session. In the hands-on session, I will show you how to solve a simple problem in pattern recognition. Uh, yeah. Yeah, one more comment I got, sir, how to detect characters from an image. Definitely, I will come back to this point after finishing the session. I will definitely come back to you. Definitely, how to detect characters. Again, the same thing. You have to apply the pattern recognition system. You have to extract the features. You have to again arrange the features in terms of feature vectors. Then, if you need feature reduction, okay, it's fine. If it is not, also it's fine. Then you can apply some classifiers, and that will help you to classify the images. But the important characters from the image, And if it is a single character, atomic character, then it is pretty easy. But if it is a sentence, then how do you do that? So then again, you have to apply some segmentation algorithm. I hope you are listening to me. And you have to apply some segmentation algorithm. You have to segment the line first, then you have to segment the word, then from the word you have to segment each is character, and then you have to apply the feature extraction techniques on each of the character, and then now you can match with the characters whatever you are already having. So a lot of things are there. So you just start reading some papers in optical character recognition. It is actually one of the one of the best or the, you can say one of the successful applications of pattern recognition, and very old as well. But still works are going on. Still works are going on because Indic languages are actually pretty difficult to even sometimes recognize by the human beings. So pretty difficult. So let us discuss something. It's very interesting that machine learning, as I already told you, that all are related words, and there is something. It's all are related things. Both are interrelated. As I already told you, that pattern recognition is a kind of problem, but machine learning is a kind of solution. That should be the answer. And the prerequisites to understand the pattern recognition algorithms should always be linear algebra. If you know little bit of linear algebra, little bit of probability theory, statistics, and after all, the programming is everything in machine learning. Whether it is, I don't actually bother whether it is Python, whether it is MATLAB. If you know the concept, yes, of course, Python is more desirable and more. I mean, it is suggested to use Python because the most of the industries are working on this, and still there are a lot of people still they are working on MATLAB because it's a kind of the most difficult in MATLAB is it is not a free software, and but still people are working on it. And my favorite was definitely MATLAB because when I was in my master and PhD, and at that time I was using MATLAB. Till now also I'm using MATLAB. I have just now shifted to Python. That's okay. But the most important thing to understand the mathematical things, if you are bit clear of that particular algorithm, and then you have to implement it. Do not. My suggestion will be: do not use the functions whatever is available with MATLAB and Python. I mean the TensorFlow or Scikit-learn or the Keras library. So do not use it. So the machine learning is such a thing. If you will implement by yourself at least 2-3 algorithms by yourself, you will feel like yes, I have done something. Every concept will be clear and crystal after implementing all the algorithms. So today we'll be discussing one algorithm. So tomorrow I will be definitely asking the same question to you, that how many of you have implemented that algorithm. Very important. If you can implement that algorithm by using any data set, I will also give you the data set name which is available in both MATLAB and Python. So then can you write the algorithm by yourself without using any function, without using any predefined function which is available in Python and MATLAB, and can you write it? If you can write it, then you will feel really good and you will feel confident. Yes, I can do something in MATLAB. I mean, you can change also. Whenever you write your own code, you can change it. You can change the parameter. You can make some changes. You can make some improvements in the code as well. So that's the most important thing. Is please suggest your students to write the program, to write the program and to implement all the algorithms, whatever the algorithms is present in pattern recognition as well as the machine learning. Very important. So I will be not discussing more than that machine learning for pattern recognition. And we all know that there are a lot of learning algorithms are there. I mean, there are some statistical models which are basically used for pattern analyzing the patterns. And there is something called as artificial neural network, very famous. You all know that. There are something called as cornell methods, SBMs and others. And the recent one, the most recent one is the deep learning model, so which I will not discuss right now, because if I will start discussing on deep learning, then you will tell sir why I'm discussing then pattern recognition right now. So yeah, fine. Deep learning has a lot of applications, a lot of advantages, and also it requires a lot of things which are not always available with us. So that if time permits, that will be discussed tomorrow. That what exactly the difference between machine learning and deep learning is. So coming to this figure, as I already said you that there are some relations. There are some relation which is present in between pattern recognition and machine learning. You can see I have shown a Venn diagram out here, and how related the pattern recognition machine learning and the pattern recognition AI, pattern recognition data mining. These are the different terms provided by the scientists and the researchers: data analytics, machine intelligence, data mining, knowledge data discovery, machine learning. Again, there is something called as deep learning, AI, pattern recognition, neurocomputing, and these all are, as I said, all are related. And machine learning, coming to the definition, yes, the same thing, learn the machines to mimic like human being without being explicitly programmed. You should not write. You cannot even think of writing a program. How can you write a program if I'll give a task the same question? I think one participant has asked, sir, how do you recognize characters from the images? Can you write a C program? Can you write a C++ program to do the, to recognize the patterns? Can you write? You cannot write. Why? Because you don't know how it is done in your brain. So that's why this type of algorithms that came into the picture, and this machine learning algorithms and this pattern recognition algorithms, these recognition algorithms will be helpful in this type of applications. Yeah, this is a very common thing. You all know that there are two different types of pattern recognition or machine learning algorithms: supervised and unsupervised. The major difference between the supervised and unsupervised is whenever you are provided with a data, the output level will be there. In case of supervised, I mean, the teacher will be there who will guide you all the time that that whether you are doing going in the right direction or not. So very, very important. So that is why I have also mentioned it mathematically that xn is n is nothing but the sample number which varies from 1 to capital N, and that belongs to RD. I mean, these are nothing. X is nothing but a feature vector that may contain 4 features, 5 features, or 10 features. This is nothing but a vector, and RD is nothing but the real values in D dimension. So maybe the feature is of D dimension, and all features contains of real values. That's why we are treating it as a random variable in probability theory. So prediction, yeah, supervised classification, supervised in supervised learning, as I already mentioned, that you have to work with the output level. So that is why and the problems like prediction and classifications are coming under these categories, and because you should have that knowledge, a priori knowledge of that whether that particular animal is a tiger and cat. And there are two different types of problems out here. One is classification and regression. And the difference between the classification and regression, many people many people even don't answer this question. They could not able to answer this question. Why? Because it is pretty simple. The classification is that there's something to classify. Yes, that is the definition. But what is the actual definition? I mean, the difference, technical difference between these two is in classification, the output levels are like 0, 1, 2, 3 for discrete. And but in regression, you know that regression problems are nothing but stock exchange prediction, dollar value prediction, rainfall prediction. So these are definitely real values. This cannot be a discrete values. So this is the major difference between classification and regression. And coming to the unsupervised, you all know that how powerful unsupervised and how challenging unsupervised is, because you will be provided only the data and there will be no class level. So from those data itself, you have to find out the similarity and design the groups similarity based on the similarity measures. So that's why the problem is called as clustering. And there are some dimension reduction techniques which are also coming under unsupervised learning, like PCA. And in bracket I've written not all. That means there are also some dimension reduction techniques which are coming under supervised learning, supervised category. So here, that's why I have not written anything. Why? Because Y is not available with us. So to make you understand, so this is the figure. I have taken it from some internet somewhere. So you can see the supervised means there are some dog images, cat images, and finally this is a classification problem, and so you have to provide a label to each of the images as a dog, and cat. But the major challenge in unsupervised is given a set of images, how do you distinguish, or how do you group, how do you cluster the images of the similar categories. So based on the some similarity measure, there are some similarity measure, and a lot of algorithms are there for this. And so you have to just a minute. Yeah. So so this is pretty simple to understand the concept here, that how to, the dogs are of same categories, but the difficulty here is you all know that the first one is dog and the second one is also dog here. So can you see the picture on the screen? See, the properties are totally different, the looks are different, color are different, but still we could able to tell that yes, both are the dog images, because that much of intelligence we are having already, and that intelligence you have to put in your system, very difficult. So again, coming back to the pattern recognition structure of both categories, you all know we have already discussed. If you are having some documents, images, signals, sounds, sentences, then you have to first extract the features from it, and then you have to provide to the machine learning algorithm. But if you can see here is the labels are there. Labels are there to guide and to build the model. So next time, whenever in the testing time, whenever you will pass the feature vector you will pass the images to the feature extraction technologies, and then the model is already trained. And that's why we are not again training the model, because the model is already trained, and you can now take the help of those model, and you can simply predict what exactly the level is. And coming to the unsupervised, everything is same. If you can see here, the difference between these two figures is the labels are here in supervised learning, but the labels are not here, because you are now going to solve a unsupervised problem. And a lot of problems which we've already discussed. The face identity, facial expression is one of the most vital pattern recognition problem. And how do you recognize the emotions? In which, I mean, the stages, the emotions, whether you are in angry mode, whether you are in a happy mode, whether you are in a cool mode. There are a lot of different disgust mode. So there are a lot of different facial expressions people use to give every day in real life. And can you identify those emotions? So face detection is a different problem. Face detection in the wild is a different problem. Face recognition is a different problem. Face facial expression is a different problem. Face emotion recognition. So very, very important. These are the problems actually which are currently being solved by using means of machine learning and deep learning algorithms. Coming back to this problem which we have been discussing, the image classification problem. So tiger, let's say there are four varieties of animals are there, and if I will ask you to distinguish those samples, I mean to find out the level or to classify those those images, you can easily do that. But if you look at the images, it's not that easy for the machine to do that, because if you look at the images in the first row, all the images are the images of the tigers, and the location of the tigers, the appearance of the tigers, everything is different. Everything is different, and sometimes even only the face part is there in one image, but still we could able to achieve. I mean, we could able to classify just yes, it's a tiger. So that much intelligence we need to put to our system. I mean, that type of feature, that type of classifier, you have to design the robust classifier. So again, there is something called a scene image classification. So a lot of things are there. So coming to the medical image classification, you want to classify the images into categories. I mean, the normal, these are nothing but the MRI images of the brain, and the views are the top views, axial views you can do. So normal MRI brains, if you can see, and the abnormalities are present in the actually the second row. In the second row, you can see the abnormalities, and actually the major difference between the first one and the second, the images in the first row and the second row is actually the symmetricity of the. There is something we can see X kind of structure in the first row. X kind of, this is actually nothing but a cerebrospinal fluid present in the brain, and if you see that structure is disturbed in all the images present in the second row, that leads to some kind of abnormalities in the brain. That's what. So again, we have to design some automated CAD system or pattern recognition system to distinguish whether the person is having normal brain or abnormal brain. And a very interesting problem, there is something called as food recognition. So food recognition itself is a problem, and there is something called as multi-food is again one more challenge added I have here, that multi-food recognition. So it is not that easy. For us, it is rather easy. And sometimes even it is very difficult. If I'll show you there are varieties of teas and varieties of coffees are there. So if I'll take a picture of coffee and tea, so even you cannot tell that whether it is a coffee and whether it is tea. So because there is a large interclass, there is a large interclass similarity between this tea and that type of tea. So again, one more challenges I have added out here, that multi-food recognition. If one plate is containing multiple foods, so multiple varieties of foods, can you recognize that and can you detect fast? If you are detecting it, then can you recognize it? So what exactly, why it is required? Where is the application? So by which you can calculate that how much nutrition or how much vitamin you have taken or consumed in a day. So see where the world is going. Every day there is something new problem is coming, and how the researchers are thinking and what is their thought process and what is our thought process. So this is not, it's not a problem of multi-code recognition. Even they are thinking of where to utilize this type of thing. So very important actually this type of problem. Now you can also take up this type of problem because till now I don't know that. I hope that there are 2 3 papers which were published in India based on this food recognition and food identification problem. Because in India it's a very interesting as well. Similar to, as I told, that if you go to every state you will find different languages, and again the style of writing and everything is different. So similar to that, if you go to different states, you will find a lot of local foods, and then it needs really some automations to find out that what type of food it is. And sometimes, if some people from abroad will come, they can take the picture of this food and they can put it in the website or in our model, and then that model will tell definitely what it is the name of this food. Again, the researches are currently going on. If you detect, if you once you detect that what type of food it is, and then it will tell you the recipe. That so very interesting problem actually this is. So coming to the technical things, so how do you represent the features? So how do you represent the features? So features, as I already mentioned, so in a classification task we are given a pattern, an image. So the task is to classify the pattern into any class. I mean, if let's say there are a small c number of classes are there, so your job is to classify a feature vector or a pattern. The feature vectors are generally derived from each of the patterns, which clearly describes that pattern uniquely. And you can see right now I have shown here something called as x is equal to x1 x2 up to xd. So x is nothing but a feature vector which contains how many features? Now d number of features, and all features are real values, and that is why I have written here r to the power d, which is nothing but the symbol of the real values, and it is of d dimension. So what we assume here is each pattern is represented uniquely by a single feature, and that it can, so that it can belong to only one class. Otherwise, there will be some problem. So if you find there are some redundant features, so from the redundant features, you cannot even predict whether the particular pattern will belong to one category or 2 categories, because if the redundant features should be there, so that may create a problem. And so again, coming back to the classification problem, we have already discussed, right? This kind of how do you extract the features, then apply. The training phase and testing phase here I've shown. In the training phase, if you can see here, I'm extracting the features and building the model. I mean, building the classifier. And during testing phase, simply I am passing the images in the testing phase, and these images are definitely, I mean, this is not the exact image whatever I have used for test, I mean training, and this is a bit different of the same categories but bit different one. So I mean, this is an unknown sample of the same categories, and I would like to predict or to classify this particular sample and pattern into different categories. I mean, one category is the correct categories. So similarly, I will extract the features whatever is there, and these feature vectors whatever you are extracting has some has some concern out here, that what type of feature you will extract from the model. That exactly depends upon your expertise, or you may take help of the papers which are published in top journals or top conferences, that what type of features are currently being used, and is there any other feature which are good than, which are better than that features. And in deep learning, actually, it is automatic. The features are extracted automatically by using a lot of layers. So the feature extraction here, this process is called as feature engineering, and the features are called as handcrafted features, because we are the one who is applying some technologies, image processing algorithms, signal processing algorithms to extract the features from the images. So classification. So finally, you will get to know that yes, there is something, or you will provide a level to this particular sample is nothing but a tiger. So a lot of the measures are there, performance measures are there. So I should not discuss all these things. You can learn if you are aware of this. Then it's too good that whenever you are solving a classification problem, there is something called as a confusion matrix. There the parameters are like true positive, true negative, false positive, and by using that you can find a lot of measures like accuracy, specificity, sensitivity, precision, recall, a lot of things are there, F1 score, MCC. So a lot of things are there. I mean, why it is required? How do you know that your model is better than other model? Like if you are a computer science person, then you are better acquainted with the algorithm subject. And in algorithm, whenever you are comparing with one sorting algorithm with another sorting algorithm, and you know there is something called as time complexity to measure and to evaluate the algorithm, whether that algorithm is better and this algorithm is better. So like that, in time complexity and space complexity, you are calculating for that. So here also something called as performance measure in terms of confusion matrix, or in terms of accuracy, sensitivity, specificity, F1 score, and a lot of precision. So then how do you know that whether there is a success or not? You all know that because we are going to solve, we are solving a supervised problem, and we are dividing the data set into two categories, training and testing. So to test, the training model is basically used to train the model, to build the model, and testing is to test that how the model is behaving on the unknown sample. So but whenever you are designing a model, so you should keep in your mind that your model should behave good on both the set, training as well as testing. So then only you can tell, yes, your model is a robust model or a reliable model. So success is what is nothing but the actual output which you are getting from the which you are getting from your model, and there is something called as a target or desired output which are given already. You can match with that. If it is matching, so then how many samples out of all testing samples, how many of the samples are correctly classified and how many are misclassified? So the how many, let's say there are 100 number of testing samples are there, and out of that 98 are correctly classified, and the accuracy will be 98%, and you can easily find out the error based on this. Sure. These are the measures which you have to evaluate. I mean, we have to measure to check whether your model is better than other model or not. So I've already talked about training and testing. The goal of the PR system is to perform well on both training and testing data. And the error on the training data is called as training error, and the error in the testing set is called test error. The test error is sometimes called as generalization error, because the testing and generalization is very important term. So generalization is very, very important in the pattern recognition and machine learning task. Why? Because it actually tells or represents, if the model is having good generalization, means it is performing well on the new data. So if it is performing very well on the new data, on the unknown data, so then the model is having good, the model is well generalized. And if and the testing error, that is why is known as generalization error, it should be reduced. So right now we are moving towards something called as Bayesian decision theory. So Bayesian decision theory, I mean, right now we are going to discuss the first recognized, the first recognition algorithm or classifier, which is based on a probability theory and otherwise called as a naive Bayes classifier. So we will be discussing the naive Bayes classifier, and today, if I don't know whether time is there or not, let's try to discuss first the fundamental things behind the Bayesian decision theory, and how probability theory will be helpful to distinguish the patterns into different categories. So Bayesian classifier can be applied. Bayesian classifier can be applied to two-class classification problem. It can also be applied to multi-class classification problem. That we will see. Even tomorrow we will be having one hands-on session on it. And just to tell you, just to inform you that just tell me, just tell me one thing that let's say you want to say for example, what I want to say is, yeah. So let's say I want my child to take admission to get admission into one coaching center or one institute or one, let's say, a medical coaching center which is there in Kota. So what I will first see, the success rate, right? The success rate, the probability rate. So the success rate they have shown was that out of 500 students last year, 400 students have got medical. I mean, got cracked in medical entrance examination. They cracked. So that means out of 500, 400 students get through the medical entrance examinations. So I could able to think at that time, right? Yeah, for I mean some percentage, there is some high percentage of chance that my child also will get, I mean, will crack the medical entrance examination. So that is the simple. Even we are always thinking. So we are also always classifying the patterns by using simple probability theory. And this probability is called as actually prior probability. I mean, out of 500, 400 got first class. So there is a high chance of getting cracked in medical entrance examination. So that's why I will definitely want my child to put into that particular coaching center. But the question is, let's say there are a few good, maybe that information was wrong, and I found there is something a very good coaching center. The faculties are very top in that coaching center, and in the coaching center, what I could able to see is the statistics is out of 500, 250 got get through or got through the entrance examination. So now the situation is 50-50. So then, how would you decide at this time? How would you decide whether you will put your child in that coaching center or not? So here the problem comes when both the classes, yes or no, the classes are having similar or equal probability. So then now the question is, how will you decide? So this is the situation where naive Bayes classifier will help you out, and the equation of the best naive Bayes will help you out to find out the class level correctly. So before I discuss about naive Bayes classifier, I should discuss about something called as probability distribution, because the as I already told you that naive Bayes is totally dependent upon the probability distribution concept. So we should first know at least, can we represent the data of a class in terms of probability distribution? Yes, it's correct. The data of a particular class can be represented using a probability distribution. And if the data forms a single cluster, like the example I have shown you, if you could remember that sample, I mean that example of I could what I have I think shown to you in case of salmon and the decision boundary, that all the samples of the salmon forms a single cluster, and all the samples of the sea bass forms another cluster. So if the data forms a cluster, we can predict and we can represent that data by means of a Gaussian distribution. Very, very important. The role of Gaussian distribution is very important in pattern recognition and machine learning. And to understand this concept, you should have some little bit of understanding in probability theory. So the normal and Gaussian distribution, it is otherwise called as normal distribution. So distributions, you all know that random variables are always represented in terms of probability distribution function, and because it is continuous in nature, and you all know that features are continuous in nature, and so that it can be represented using Gaussian distribution. But why Gaussian distribution? So my question is, why not exponential? Why not relay? Why not uniform distribution? Why Gaussian distribution? Why Gaussian distribution is always taught in pattern recognition and machine learning? So this is a common question. Even people used to ask in the interview. So the answer is the Gaussian distribution. There are two different things what Gaussian distribution actually holds. The one is the mathematical easiness, the mathematical tractability, and the second one is the very important thing, the central limit theorem. So because of these two reasons, Gaussian distribution has gained a lot of attractions or attentions in the field of pattern recognition and machine learning. So in simple terms, if I will explain what is the theorem, and the theorem says that if you are having many independent variables, I mean all the features, whatever you are extracted, all independent variables, random variables, that may be generated. We don't know that always whenever you are generating some data means that follows some distribution, and that we don't know what kind of distribution it is. Even you cannot predict that always this data always forms a cluster, and this will always lead to Gaussian distribution. No, it may be generated from different types of distribution, but the most important thing, the central limit theorem says that whenever you will aggregate or concatenate those variables, that will tend towards the normal distribution and Gaussian distribution, and that is why the Gaussian distribution is being used in pattern recognition task. I hope you have understood it clearly, that what is the probability distribution and why it is required, and what is the role of distribution in pattern recognition. Sure, but if you can see the what is univariate Gaussian distribution out here. So univariate means, let's say you are having only one feature where the data is only one dimensional. If the data is only one dimensional, so definitely you have to apply univariate Gaussian x versus f of x. So, and you all know the equation of the Gaussian distribution, 1 by root over of 2 pi sigma. Sigma is nothing but the width of the bell-shaped structure. You can see right here in this particular figure, and e to the power exponential to the power minus of x minus mu square by 2 sigma square. So this is nothing but sigma square is a variance out here, and x minus mu square is nothing but the distance of the sample of different samples from the mean. So this is what this is how the univariate or the single one-dimensional Gaussian distribution or normal distribution looks like, the graph and the equation as well. But you all know that in real life the features will be definitely multi-dimensional. The features will be d-dimensional, and the d value can be anything. And then at that time, how will you represent the distribution, and what is the formula of the p of x? I mean the distribution formula. So the distribution formula in case of multivariate, if you can see, is nothing but 1 by 2 to the power 2 pi to the power d by 2, where d is nothing but the dimension of the feature vector. If you are solving a four-dimensional feature vector, or if you are representing your samples in terms of four features, so definitely that value of the d will be 4. And there is something called as here covariance matrix. So there is something called as covariance matrix. Whenever you are solving a problem in multidimensional, in d-dimensional space, you cannot use simple variance sigma square. Rather, you have to calculate the variance for each of the feature, sigma 1 square, sigma 2 square, and you have to also calculate the correlation between each of the feature, and finally it forms what? Finally it forms a matrix. If you can see, let's say my d value is 2 here, x1 and x2 are nothing but the two different feature values, and my vector consists of two different features, x1 and x2, and definitely if my number of features are 2, and my mean vector will be definitely of size 1 cross 2. I mean the mean vector is also having size mu1 and mu2, you can see. So that means if my number of features are d, so definitely the mu vector is also be a d-dimensional vector. But you have to remember one thing, that covariance matrix will be of d cross d. So in case of 2 cross 2, if you can see, sigma 1 square, the variance of the class 1 feature 1, the variance of the second variable, and sigma 1 2 and sigma 2 1, and the properties of the covariance matrix is nothing but a semi-definite symmetric matrix. So symmetric matrix, it is always a symmetric matrix. And you know what do you mean by a symmetric matrix? As I already told you, that you need a little bit of idea of linear algebra and probability theory to really understand the mathematics things behind this multivariate Gaussian distribution. So the formula, if you can look at here, is the C is nothing but, sometimes in some book it is represented as sigma, in some book it is represented as S, capital sigma, and here I'm talking about a capital C. Small c I have taken for the number of classes, capital C I have taken for, covariance. I have to, covariance matrix. Yes. So this formula 1 by 2 to the power d by 2, determinant of C. C is a matrix. So determinant to the power 0.5, and again e to the power, the same formula, whatever we have used, that x minus mu square actually. So x minus mu square, that means the difference between difference or the distance between the mean vector to the each samples. So this is how actually the multivariate Gaussian distribution looks like. So if you want to implement this equation, how will you implement? So let us try to solve a problem based on that, and then only you can easily do that. And as I already mentioned, if the data is of d dimension, so of course, I mean your feature vector is 1 cross d vector, and the size of the mean vector should be 1 cross d, because this is nothing but the mean of the each feature vector. So size of the covariance matrix will be always be d cross d. Dimension of the d cross d will be always. And for bivariate, for 2-dimensional, the maximum graph you can draw is 3D. So you can see the 3D, and also it looks like a bell-shaped curve. And if you cut the curve, and it will look like ellipse. So it depends upon the actually the value of the matrix C and mu vector. C matrix and mu vector, that whether it will look like a circle or sphere or a what is that, ellipse. So let us solve this problem by ourselves and compute the value. The question here is compute the value of a Gaussian PDF probability distribution function given. I mean, it is represented in terms of n, and there are two parameters, as I already mentioned. And there are two parameters. One is C, and the one is mu. X is given, pi, you all know that, and d can be calculated from the feature vector. So the two parameters are nothing but mu and C, which are generally calculated from the data. So here mu and C values are given to us, and as I already told you that C matrix is a symmetric matrix, and here you can see this is the identity matrix as well as symmetric matrix. And the mu is nothing but here the x1 and x2. So I think by mistakenly I have not written. I have written here x1. Actually, the second one is x2. So the first feature vector is x1, and I want to find out the Gaussian PDF at this point for this particular sample, for this particular feature vector. So how will you calculate that? So just replace x by x1 and put all the values. Put all the values in the equation, and you will get one value. So the final probability value, the probability distribution value, will be a single value. And just the one thing you remember, so whenever you will implement it, be careful about the matrix sizes, matrix dimensions. So I mean e to the power, it should be a single value. E to the power single value. Otherwise, e to the power a matrix cannot give you a correct value. It will lead to some wrong things. So e to the power a single value. How it will be a single value? Now x minus mu, you will represent in terms of 1 cross 2. Then C inverse, it is 2 cross 2. So whenever you will multiply 1 cross 2 into 2 cross 2, the value will be 1 cross 2. And x minus mu is nothing but the transpose of the x minus mu transpose, and which is nothing but 2 cross 1. And the original one is 1 cross 2, multiplied by 2 cross 2 is 1 cross 2. And then is nothing but the 2 cross 1. 1 cross 2 into 2 cross 1, you all know that chain multiplication will give you 1 cross 1. So finally, it will be multiplied by minus 0.5, and it is nothing but e to the power a value. And these 2 pi to the power d by 2, here d is nothing but it is a 2, and it is 2-dimensional value, and you will definitely get a single value or constant value will be multiplied by e to the power something, and finally you will get p of x1. Again, for p of x2, you just replace the x value by x2 and then find out the value. So now it is your task is to calculate whether I don't know whether these values are correct or not. You just please check either using MATLAB or Python. So you just implement this equation, and then you can take a snap of this particular slide, and you can tell me the answers tomorrow, that whether, because this is very important to design Bayesian classifier. Till now we have not yet discussed Bayesian classifier. We are discussing the prerequisites which are required to design Bayesian classifier. So Sandeep sir, are you there?
Yes sir, I am there.
Yeah, so if I will start discussing Bayesian, actually tomorrow I will start, I mean, I will discuss first the algorithm and then followed by the hands-on session. Because tomorrow also we'll get 1.5 hour for the hands-on. So I will
Yes,
first
yes.
discuss the theory, then followed by, and if time permits also, I will also discuss one more algorithm, fundamental algorithm we are talking about. There are a lot of advances in even neural network, extreme learning machine, random vector functional neural network. There are a lot of things which are there advances, but this particular workshop is a really great workshop. But they are actually PIT people are organizing. They want to build the foundations of the machine learning. I mean the image processing, and there are some applications of image processing like pattern advances in image processing like pattern recognition and others. So, sir, what do you want? So tomorrow, first we will discuss, and then we will be, uh, conducting one hands-on session. I think that will be good because the algorithm followed by the will be good. And actually, it is the time is 3:35, right?
Yes, yes, sir.
Now we have almost finished the introduction to by pattern recognition, the fundamental knowledge. The only algorithm we have not discussed, and it will take not more than 15 minutes. So tomorrow we will first take 10-15 minutes to discuss about the algorithm, and then we will discuss. And now you will, I mean, we will try to implement the algorithm by means of either by using MATLAB or Python.
No issue, sir. I don't have any problem. As you wish. Like it is up to you, like how you are going to have the sessions. We have two sessions tomorrow.
Yeah, yeah.
First session will be at 11 o'clock. Sorry, 11:45, and then
11:45, sir.
second one is at 2 o'clock. So as per the schedule, first one will be hands-on on the pattern recognition, and second one will be introduction of image processing. Now it is up to you, sir, how you need to take. It is totally up
Yeah,
to
yeah,
you.
yeah.
Have
Thank
any
you so
issue.
much. Then, so we can easily handle tomorrow because tomorrow we are having two different sessions, and the last session will be very fruitful, of course, because medical imaging is currently a very vital topic to, and then so many researchers are going on in this particular field. And if somebody is really working towards their doctorate degree, and even somebody those who have already completed their PhD degree and working in this field, they can also take up a problem and they can pick up a problem out of that, and they can build their career, and they can publish a lot of articles in top journals and top conferences. Tomorrow we'll be talking about some of the good conferences and how to find out good conferences, and what are the good conferences, and what are the good journals in the field of pattern recognition. If time permits, I can talk about on that 5 minutes or 10 minutes, that how do you know that whether that journal is a good journal, and how do you believe that yes, this journal, and reading that paper. And sometimes it is very important, the paper which you are following, whether that paper is a reliable paper or not. Otherwise you will try to implement that paper, you will not get that output, and you will be frustrated. And that happens actually all the time. So we'll be discussing. And is there any questions from the participant side? And if is there any comment is there, even it is welcome. So if any comment is there, also it is welcome.
Definitely, sir. If someone have any question or any doubt, so you can ask now, or you can unmute yourself and you can talk to sir directly. Yes. Okay,
Uh,
sir.
if,
Like, let
if,
us.
if anybody if anybody is having any doubt or any questions, they can contact me via email. So I'm writing
Yes.
my email right now, drnaik at IEEE.org. So this is my personal email ID. You can send it if you are having any doubt, and if you want any kind of collaboration and other things, then you can write to this email ID. So thank you once again, Sandeep sir.